Hello everyone. My name is MD Shahab Uddin. I am a second-year master's student at Concordia University. I am honored to present our paper, Horus, a security assessment framework for Android crypto wallets. This work is a collaboration with Professor Mohammad Mannan and Professor Youssef. This is the outline of my talk. First, I will provide an introduction and background. Then I will talk about threat model and methodology. Finally, I will discuss results and conclusion. We have seen massive adoption and growth of cryptocurrency in recent years. The most popular cryptocurrency, Bitcoin's value, has surpassed $60,000 in 2021. This is the highest value reached by any cryptocurrency in history. The combined market cap of more than 6,000 cryptocurrencies have reached a new high of $1.24 trillion in value. As of 2021, at least 21 countries made cryptocurrency exchange and trading illegal, including Australia, Canada, Japan, and United States. Massive growth of cryptocurrencies comes with increasing number of threat vectors. In 2020, the crypto community has witnessed no less than 34 attacks, breaches, and scams. A hacker group named CryptoCore has stolen more than $200 million worth of crypto assets from cryptocurrency exchanges. By exploiting a Bitcoin wallet update vulnerability, criminals capture more than $22 million worth of assets. In recent years, several analyses have been conducted on wallet apps. By abusing accessibility permission and USB debugging technique, attacker can capture sensitive information. Hu et al. Demonstrate 3 attack scenarios which targets de-anonymization, spamming, and violating peer-to-peer requirements of Bitcoin protocol. Another group of researchers analyzed forensic artifacts of wallet apps and developed a Trojan as a proof of concept by repackaging a wallet app to steal user credentials. A crypto wallet app is a key store that contains private and public keys. On behalf of the user, it can create new keys, manage the keys, and user can take backup of the keys. User can sign transactions using wallet apps and keeps track of funds. There are 2 types of wallet based on how they generate keys: non-deterministic and deterministic. HD or hierarchical deterministic is the most popular scheme of deterministic wallet. Non-deterministic wallet is a collection of randomly generated keys. There is no relation between the one key to the next. Each key is used for one transaction in an attempt to make the user anonymized. The downside of this approach is that the wallet requires regular backup, ideally after each transaction. User needs to keep the backup file in a safe location. If user would like to move to a new wallet, the user needs to export keys from old wallet and import in a new wallet. If the process is not done with caution, there is a risk of key exposure. Because the export file is created in publicly accessible storage, and any other app with read storage permission can read the file. However, the file is encrypted with a user-provided PIN, but a PIN is a maximum of 6 digits number and can easily be brute forced. Deterministic wallet is getting wider acceptance in wallet ecosystem. The benefits of HD wallet is that it's portable and can be used simultaneously with multiple client apps without the need for regular export-import. All the keys are generated from a seed and orders as a tree structure. Each branch of the tree represents a particular type of currency. For example, KM0 is Bitcoin, KM1 is Ethereum, etc. Each grandchild key is used for one transaction of that currency. Only one-time backup of the seed is enough. And the same seed can be used for any number of cryptocurrency accounts. Steps to generate HD wallet. First, a random seed is generated that is used to create a mnemonic phrase. Usually, the mnemonic phrase is a 12 or 24 words long phrase. In Android, almost all the wallets use 12 words phrase. The phrase is used to generate a seed, and eventually the seed is used to generate master private key. To collect a dataset, we have developed a scraper module that can search and download apps from Play Store based on a specific search term. We have collected 310 apps and shortlisted most popular 17 apps for a more in-depth inspection. For the shortlisted apps, we consider apps that have at least 1 million plus downloads. We assume attacker can install a malicious app on the victim's device with any of the following capabilities. The malicious app can have a virtual keyboard permission or accessibility permission for taking screenshots. We assume the user's device is not rooted. However, the malicious app can successfully root the device. The attacker can have physical access of the unlocked device for a few minutes to execute ADB command. Now we present our security assessment framework, Horus, to detect and evaluate security issues in wallet apps. We perform two types of analysis, static analysis and dynamic analysis. We use state-of-the-art tools for performing static and dynamic analysis. Additionally, we conduct manual inspection to understand the app's security practices and evaluate the security risk associated with them. In static analysis, we look for certain security standards and best practices are followed by the app or not. For example, secure random number generation is crucial to generate seed. Wallet apps should implement custom keyboard because to import a wallet in a new app, the user needs to type the mnemonic phrase. The mnemonic phrase consists of most common English words, and the user dictionary can be exploited to predict the typed words. Disabling screenshot is also important. When the mnemonic phrase is displayed, a malicious app can take the screenshot. Integrity check should be performed by the wallet app to ensure it's being installed from a legit source like Google Play Store. And app should be capable of detecting if the device is rooted, and upon a positive detection, the app should close itself. Lastly, app should utilize hardware security module. It's a separate process and can store private information. Even if the OS is compromised, HSM can still protect the private information. However, it is only available on high-end newer devices. We are generating call graph of the app to determine if certain feature is implemented. Call graph contains class name, method parameters, return type, etc. If the call graph contains certain API calls that require to implement a functionality, then we can say the functionality is present in the app. For automated analysis, we have used state-of-the-art static analysis tools to look for generic vulnerabilities. For in-depth inspection, we use reverse engineering to discover permissions usage and the possibility of sending crafted intent to exploit exported components. We skip manual inspection if the code is obfuscated because of the absence of meaningful information in obfuscated code. The basis of our dynamic analysis on HT Wallet is that the mnemonic phase is portable. We use same mnemonic phase and import it in all wallet apps. We make a transaction to a predefined address and the amount is also specific. Then we run dynamic analysis and analyze the artifacts of the app. By artifacts, we mean internal files, network and logs, dump, etc. We generate a list of search keys and look for the keys in artifacts. For example, mnemonic phase is a key revealing information and needs to be protected. In Android, AES is the most popular encryption algorithm. We are encrypting mnemonic phase with AES algorithm using all possible 4 and 6 digits PIN and appending the ciphertext in search term. We are also appending the mnemonic phase as plain text in search term. Now, if we find any element of search term in the app's artifact and the device's internal files are exposed, then the user is in danger of exposed wallet. In addition to mnemonic phase, we are also encrypting master private key, seed hex value, child private key, etc. And as potential encryption key, we are exhaustively using all values found in apps databases and shared preferences files. We are using AES and second most popular Blowfish algorithm in Android ecosystem and generating the search term list. For non-HT wallets, we cannot generate the keys by ourselves. Keys are generated by the apps. So instead of looking for exact keys, we are using pattern matching regex to look for private or public keys in the artifacts. Starting Android 7.0, system-wide user certificates are not accepted in Android. As of Android 9, plain text traffic is not allowed and cannot be configured as well. To overcome this, we use rooted device and place custom certificate in the system certificate folder to see network traffic in plain text. To make Horus fully automated, we evaluate tools like Monkey and DroidBot. Pseudo-random events generated by Monkey and DroidBot's requirement of customized script for each app made both solutions unsuitable for our purpose, and we settled for building Horus as semi-automated framework. Static analysis is not reliable and indicate only presence of certain APIs, but we cannot make sure if the implementation is proper. So it's possible that an app calls certain API, but the implementation is erroneous. I will present some important results we have found through our analysis. We found 111 apps are storing key revealing information in plain text. 18 HT wallet apps are storing encryption key without additional protection. In most cases, encryption key is stored in the device, or app are using user-provided 4 to 6 digits PIN as encryption key, which is easily brute forceable. 307 apps are not using HSM, the best-in-class security storage solution available in Android. 11 apps are storing transaction information in the device, which may lead to de-anonymization. For providing predictive text inputs, Android maintains a dictionary of frequently typed words of user's choice. According to Bitcoin protocol, mnemonic phrase contains English words, and most apps take mnemonic phrase input via default keyboard. This action leaves traces of mnemonic phrase in the dictionary and can be exploited to reconstruct the mnemonic phrase. Only 20 apps implement custom keyboards to defend against this attack. Allow backup is a Boolean attribute declared in Android manifest file, and it's true by default. It denotes app data can be backed up upon the app's uninstallation and is restored upon reinstallation. It also enables attacker to get access to the app's internal files, such as database, which is otherwise not accessible. 134 apps have enabled allow backup attribute in their manifest file. This attack requires physical access of the unlocked device for a few minutes and does not require root permission. In Android ecosystem, some permissions are considered dangerous and require users' explicit consent. Most wallet apps require some common set of dangerous permissions for providing their functionality, such as accessing camera for scanning QR code. However, some apps asking for additional dangerous permissions without a proper need, such as recording audio, accessing contacts, and users' location. Summary of contributions. We developed a semi-automated framework to statically analyze wallet applications and perform dynamic analysis. Our static analysis is fully automated, and dynamic analysis require minimal manual interactions. We conducted automated analysis of 310 wallet apps, and for further analysis, we inspected most popular 17 Android apps manually. We revealed 111 applications are storing key revealing information in plain text, and 18 applications are storing encryption keys without any additional protection. We identified Android user dictionary feature can be abused to derive mnemonic phrase entered using keyboard. In conclusion, our analysis indicates that security standards are not followed when developing apps, and there are vulnerabilities in the effort of protecting key revealing information. There is a lack of checks and balances in our understanding of wallet app security and their actual implementation. Only official trusted app store should be used to download applications. And finally, sensitive permissions should not be granted to app for non-critical functionalities. Thank you very much for listening to our presentation. If you have any questions, feel free to reach out at the following email address.